In this video I just wanted to cover linear substitutions, and the best way to show you this is just through some examples. And so just a straight up example, let's have a look at this. Let's have a look at the integral of x square root 1 minus x dx. So looking at this, so far in your tool bag, do I know what the antiderivative of this is? No. Can I use a arc trigonometric function? No, that doesn't look anything like them. Can I make a substitution? Inside function here, 1 minus x, the derivative of that is negative 1. That's not x, so that's not going to work either. But what happens is that when you have an inside function which is linear, so in this case we've got that didn't change colour. When you've got an inside function that is colour, inside function that is linear, what you can do is to try and make a linear substitution, and I'll show you what I mean by that. So if we say let u be equal to 1 minus x, then what we have is du dx is equal to negative 1. But also, what we also have, we've got this x sitting out here. If we want to change all these x's to u's, why don't we just say what x is equal to in terms of u? So in other words, up here, if we rearrange this equation up here, so we move x onto this side and u onto that side, x is equal to 1 minus u, isn't it? So move x to that side, 1 minus u. So that's just a rearrangement of that. That's what x is equal to in terms of u. And so then what you can do is just change this integral. So this integral is, what is x? X is 1 minus u. Okay. Then we've got this square root of 1 minus x. What's 1 minus x? That's u. And then we have dx there. We've got du dx. We've got to get that in somehow. So we'll put du dx in here, but we don't want to make a negative, so we'll just make it negative du dx to get that in there. We need du dx to be in there, so we'll chuck it in like that, and then we've got this dx there. What happens? Those dx's cancel out, and what we'll get is this. We'll get 1 minus u to u to the half, and you'll just get this negative. I'm just going to chuck this negative out the front, du. Alright. What we do at this stage is we can just expand this out. We've got to a stage where we can do this now, and so if we expand that, you'll get u to the half minus u to the 3 halves du. We can now comfortably integrate that. We've got it to a place where we can integrate that. So that's negative, I'll just put it in brackets because we've got that negative. Could have left that negative in, it might have made it a bit simpler. So we've got u, increase that by 1, 3 over 2, divide by 3 over 2, you get 2/3. And then minus u, that 3 over 2 will go to 5 over 2, and then divide by 5 over 2. 2/5. We have that. Okay, I've made a mistake over. Plus c, like that. And now we can substitute our value of u back in to end up with an answer in x. So we get negative 2/3, u was 1 minus x, 1 minus x to the 3 over 2, plus 2/5, 1 minus x, 5 over 2, plus c, and there's your answer. Okay, so the idea of this one is just to simply with integration, a lot of times it's just giving things a go. If you look at the inside function, you go, yep, I can make a substitution for that. If it's linear, can I rearrange it to get something else out the front? If I get time, I'll try to do one more example. Let's do something like this one here. And okay. Plus 1, something like that. No, it's a bit boring, but just want to show you the principles in a 10-minute video. Okay, so let's look at this. Is that one of the trigonometric functions? No, there's no squares down there. It's plus 1, it's not minus 1, and there's an x squared at the top. Can you make a substitution? Well, the derivative of the bottom line is 1. That's not that. Can we try a linear? This is linear down here, so can we try a linear substitution? Let's give it a go. Let's just see what happens. Let u be equal to x plus 1. Therefore, du dx is equal to 1, isn't that handy? And also, what's x in terms of u? Well, we'll just rearrange it, that's u minus 1. Too easy. Now, let's substitute everything into this and let's see if it gives us something that is differentiable, that we can integrate. So let's do it. X squared. What is x? X is u minus 1, so this is u minus 1 squared. On the bottom line, we've got the square root of u, and then I'm going to stop writing it, but I'll write it. Just broke my promise. Du dx is there because it's just 1 times dx. Those dx's cancel and you just get du. Okay, so let's just do this. What I'm going to do is expand. I'll just rearrange it. So expand the top one, u squared minus 2u plus 1 over u to the half du equals, and I'll go through. U squared divided by u half, that is u to the 3 over 2. Negative 2u, so that will be minus 2u to the half, that's 2u divided by u to the half, plus 1 divided by u to the half, so that's plus u to the negative half. Du. Whoops, I lost my integral somewhere along the line there. Okay, it's equal to that. Now we can integrate that. So let's do this. 3 on 2 goes to 5 on 2. Divide by 5 on 2, 2/5. Minus 2. U goes to 3 on 2. Divide it by 3 on 2, you get 2/3. Okay. Yeah, don't make it look like 2 2/3. It's 2 times 2/3. Plus u, increase that by 1, we get half. Divide by half, you get 2 plus c. So that's equal to, now we can put the u back in, so that's x plus 1, so we get 2/5. X plus 1 to the 5 on 2 minus 4/3 x plus 1 to the 3 over 2 plus 2 x plus 1 to the half plus c. That is your answer for that. Hope that makes sense. Give linear substitution a go. They're often a good way out of a seemingly sticky situation. Thank you.